Hello, National 5, welcome to Homologous Series Lesson 5. So, like what we have been doing, here's a wee starter for you to try. So I want you to draw and name this molecule here. I want you to name and then draw the shortened molecular formula for this. Then I want you to draw cyclooctane. And then finally, I want you to write the general formula for the cycloalkanes. Okay, so pause this video. Do the starter because I'm just about to reveal the answers. Right, so we'll draw this molecule first. So first one, remember start at the left and then just draw what you see. So one carbon with 3 hydrogens around it. Now, what I also like to do first is I like to draw the longest chain. Now, remember if it's in a bracket, it means it's a branch and it's not a part of the longest chain. So how many carbons do we have? We've got 1, 2, 3, 4. So we should have 4 carbons in the longest chain. Now the very first carbon has 3 hydrogens. So we draw it like that. Okay. The next one has just 1 carbon, but it also has a branch. It has a CH3. Okay. So there it is. And then the next one, same idea. It's got a C bonded to a H, but it's also got a branch, CH3. Yeah? And then the last bit, quite easy, CH3. There it is. Okay? Now, let's name it. Okay? So, again, we try and find our longest chain. What is our longest chain? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Yep, 4 is the longest chain. So, what is the prefix for 4? It's but. And it's an alkane. So, it's butane. Okay, now, our second step, number the longest chain, starting from the side closest to the branch. Now, if we start there, the first branch is on carbon 2. If we start here, the first branch is on carbon 2. So it doesn't actually matter. So I'm just going to make the left side 1, 2, 3, 4. Okay? And what I'll do, I'll just, in fact, maybe, okay, we'll use blue. I don't think blue comes up as well. Okay? So that's our longest chain. Then what do? We circle our branches. Okay, so we've got 1 branch here. We've got 1 branch there. Now, how many carbons do we have in each branch? We've got 1 carbon. We've got 1 carbon. So, if we've only got 1 carbon in a branch, that must mean it's methyl. Okay? Now, because we've got 2 of the exact same branch, can you remember what the prefix is for 2? It's di. Okay, and then what number are the 2 branches on? Number 2 and number 3. So this becomes 2, 3 dash dimethyl butane. Okay, so well done if you got that. Right, name and then draw the shortened molecular formula. Okay, now let's get our longest branch. What is our longest branch? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5 is our longest branch. Okay, now doesn't matter what side we start from, because if we start here, 1, 2, the branches are on 3. If we start here, the branches are on 1, 2, 3. So it doesn't actually matter. I always like starting from the left if I can. So number them 1, 2, 3, 4, and 5. There's our longest chain. And then circle our branches there and there. Right, what's our longest chain? It's 5, so that becomes pentane. Okay, we've got 2 branches. Each branch has 1 carbon. So again, like the previous one, this is methyl. And because we've got 2 of them, we call this di. Okay, and then what carbon are they both on? Well, one of them is on 3, and the other one is also on 3. Yeah, remember you need to put both numbers in. So this becomes 3, 3 dash dimethyl pentane. Okay, so that one there is just sort of C above. Question 3, draw cyclooctane. Okay, now cyclos were the last thing that we did. They contain carbon-to-carbon single bonds, and they are in a ring structure. So this is the important part here. The oct, that tells us we've got 8 carbons in a ring. So if we draw 8 carbons, so that's 1, 2, 3, 4, 5, 6, 7, 8, like that. And then you've just got to remember that each carbon can only have 4 bonds coming out it. So in cycloalkanes, each carbon has 2 hydrogens coming out it, just like that. Okay? And that is how you draw cyclooctane. And the last one, write the general formula for the cycloalkanes. We've got 2 hydrogens for every carbon, so that becomes CnH2n. So, well done if you got that. Right, now, what we're going to start on now is our last hydrocarbon. Yeah, it belongs to the alkenes. Now, we did a wee bit of this at National 4 level in 3rd year, but we are going to step it up again. So there's a few things you need to know about the alkenes, okay? So, all alkenes, make sure you're getting this down, all alkenes contain at least 1 carbon-to-carbon double bond. Okay, so that's all we mean. We've got 2 bonds attached to each carbon. Okay, carbon-to-carbon double bond. Now, what else do we know about the alkenes? The general formula is CnH2n. Okay, so we've already done this one before. It's the same as the cycloalkanes. Now, because they've got the same general formula, that means they've got the potential, alkenes and cycloalkanes, to be isomers, but don't worry, we'll come on to that in a couple of lessons time. Okay, so general formula is CnH2n, and like the alkanes and like the cycloalkanes, alkenes are insoluble in water. And again, what do we mean by that term, insoluble? It means it does not dissolve in water. Okay, so they're very important. Now what we're going to do, we're going to draw a wee table. Sorry, let's try that again. So our first heading is going to be alkenes. Our next one is going to be molecular formula, and the next one is going to be our full structural formula. Okay, so if I just grab my ruler, very quickly just put this table together. Okay, now the very first one we're going to get is called ethene. Okay, now remember, think back to the very first lesson, well, all the lessons since then. What's the prefix for eth? It's 2, so that tells us we've got 2 carbons. Now if we've got 2 carbons, if we sub that into the general formula, yeah, C2H2 times 2, that would be C2H4. Okay, now if we draw that out, remember the very first one, all alkenes contain at least 1 carbon-to-carbon double bond. So we need to draw that carbon-to-carbon double bond. So that's our 1, 2 carbons. And we've got 2 hydrogens coming out of each carbon, because remember each carbon can only have 4 bonds, so that carbon's got 1, 2, 3, 4. That carbon's also got 1, 2, 3, 4. Remember the double bond counts as 2 bonds. Okay? And this here is a molecule of ethene. So we've got our 1, 2 carbons, we've got our double bond, and then we've got 2 hydrogens coming out of each one. Okay, now if we flip that over, it's the exact same molecule. Okay, just bear that in mind. Right, the next one is propene. Okay, prop because there's 3 carbons, ene because it's an alkene. So that would be C3H6. Yeah? So how do we draw that? Let's draw out our 3 carbons. Now remember, all alkenes contain at least 1 carbon to carbon double bond. So we put that carbon to carbon double bond in, and then we draw in the hydrogens. So starting this side, carbon already has 2 bonds coming out it, so that means must have 2 hydrogens to make it up to 1, 2, 3, 4. This one, this middle carbon has 1, 2, 3 bonds coming out it, so that carbon must just have 1 hydrogen. And then this one has got 1 bond coming out it, so that must have 1, 2, 3 bonds coming out it, like so. Right, now here is a propene molecule. So obviously the black ones are carbon, so we've got 1, 2, 3. We've got our double bond, which is here, yeah. And then, or if I turn it this way, we've got 2 hydrogens coming out of this carbon, yeah. We've got 1 hydrogen coming out of that carbon, and we've got 3 hydrogens coming out of this carbon. Okay. Now, if we flip this over like that, you'll notice at the carbon to carbon double bonds now on the right side, it's the same molecule. Okay, so it wouldn't matter if we drew the carbon to carbon double bond there, or if we drew it there. It's the same molecule. Okay. Now, what I'm going to do, I'm going to draw the next one. So that's 1, 2, 3, 4. Okay? Now, here is an example. Okay? Where's the carbon to carbon double bond? It's between these 2 carbons. Yeah? So we can put the carbon to carbon double bond there. Now, if I flip that, the carbon to carbon double bond's now here. So it wouldn't matter if we drew the double bond there or there, that's the same molecule. Okay? However, I've also got, so that's our original one there. I've also got this one. Now, what do you notice about the 2? This one here, the carbon to carbon double bond, is between the middle carbons. Okay, so not only can we have a carbon to carbon double bond there or there, we could also put it there, but we would need to draw that out. So that becomes like that. Okay. Now, if we put in the hydrogens, so that on the first one you get 2 hydrogens to make up 4. Second one you put 1. Third one you put 2, and then the last one you put 3. Right, now this one here, again, first one you would put 3. The second one you'd only put 1. The third one you put 1, and then the last one you put 4. Okay, now these two here, they are different molecules. Okay, because if I go back to, if I can grab it, go back to this one here, there's no way I can sort of flip that to get that carbon to carbon double bond in the middle. I need to create a brand new molecule for that. Okay, so these two here are completely different molecules. So because they're completely different molecules, they've got completely different names. Now, what we do, I'm going to make a wee note here. So when naming alkenes, we start from the side closest to the carbon to carbon double bond. Okay, and that there is so important. We start from the side closest to the carbon to carbon double bond. Okay, so what I mean by that, so this is a straight chain, so we've got the left side, we've got the right side. What side is closest to that carbon to carbon double bond? It's the left side. So we label that carbon 1, carbon 2, carbon 3, carbon 4. Okay, this one, what side is closest to a double bond? 1, 2, so well, I'll write it 1, 2, 3, 4. But if we started from the right side, 1, 2, 3, 4, the carbon to carbon double bond is between carbons 2 and 3 both times, so it doesn't actually matter in this case what side we start from. Okay, now if we do a molecular formula, both of them have the molecular formula C4H8, C4H8. Yeah, but they do have different names. Now, they've got 4 carbons, so they both belong. They both start with bute. Okay. Now, this is where it gets a wee bit trickier. We're going to make another note. Okay. So, focus on the 2 numbers where the carbon to carbon double bond is, and select the lowest number. Okay, so that again is a very important sort of rule. Now what we mean by that, we focus on the 2 numbers where the carbon to carbon double bond is and select the lowest number. So if we look in the first one, the carbon to carbon double bond is 1, 2. Yeah, it's between 1 and 2. So we focus on the lowest number, which is number 1. So what we do, we call this bute dash 1 dash, and because it's an alkene, it ends in ene. Yeah, so this molecule becomes bute 1 ene. Yeah. Now, the second one, the carbon to carbon double bond, is between carbons 2 and 3. So what's the lowest number? It's 2. So this becomes bute 2 ene. Like that. Okay? And that there is how we name our alkenes. Okay? Now, if we, I'll put the same heading. So that's alkenes. That's molecular formula, and that is full structural formula. Okay, so But again, if I just very quickly table's a bit squint, but that's okay. Right, so we've got that molecule there, and we've got that molecule there, okay? Like we said, if we were to flip, okay, so the carbon-to-carbon double bond's on the left. If we were to flip that, the carbon-to-carbon double bond is now on the right, okay? But it's the same molecule. So if it's the same molecule, it should have the same name. So let's see if we can do that. So the full structural formula, we've got 4 C's, and we've got the carbon-to-carbon double bond on the right. Now if we just fill in the hydrogens very quickly, remember each carbon can only have 4 bonds, like so, okay? Now, when we number this, what side do we start from? We start from the right side, because it's closest, yeah, closest to the carbon-to-carbon double bond. So this becomes carbon 1, 2, 3, 4. Now, focus on the carbon-to-carbon double bond, okay? So that's between carbons 1 and 2. So what's the lowest number? The lowest number is 1. So again, it's got 4 carbons, so this is bute. Focus on the 1, and then because it's an alkene, it ends in ene. So this is bute 1-ene. So it's the exact same molecule. All we've done is we've flipped it. Okay? And again, obviously that's going to be C4H8. Right. Next one, we're going to go into 5. So that's 1, 2, 3, 4, 5. Now we can have the carbon-to-carbon double bond there. So if we fill in our hydrogens, it looks something like this. Okay, and we can also have the carbon-to-carbon double bond there. Just very quickly put in your hydrogens, like so. Okay, now this molecule here, what side do we start from? We start from the left side, okay, because it's closest to the carbon-to-carbon double bond. So that becomes 1, 2, 3, 4, 5. Yeah? Now, highlight it. Highlight the carbon-to-carbon double bond. So it's between carbon 1 and 2. What number do we focus on? We focus on the 1 because it's the lowest number. Okay? So, a carbon with an alkene with 5 carbons, that is pent. And we focused on number 1. So this becomes pent 1-ene. Yeah? And it's got C5H10. Right, next one. What side is closest to carbon-to-carbon double bond? If we start there, 1, 2, the start of the carbon-to-carbon double bonds on 2. If we start here, 1, 2, 3. So the left side is closest, like so. Okay? Highlight the carbon-to-carbon double bond. And what number is it between? It's between 2 and 3. What number is low? It's number 2. So this here, because it's got 5 carbons, this becomes pent 2-ene. Okay? So it looks like that. Now, question time. I like a good question. So question. Why does pent 3-ene not exist? Okay, so let's draw it out. 1, 2, 3, 4, 5 because it's pent. It's on the third one there. Okay. So let's just very quickly remember your valencies. Let's very quickly draw that out. Now, why is it not called pent 3 and why does that not exist? Okay, for it to exist, it would need to be 1, 2, 3, 4, 5. Yeah, it's between carbons 3 and 4, and 3 is the lowest. However, we've broke a rule. We haven't started from the side closest to the carbon-to-carbon double bond, because if we did that, we would have started here. 1, 2, 3, 4, 5. Okay, so the top row is actually incorrect. Now, if we focus on the carbon-to-carbon double bond, what number is lowest between 2 and 3? It's 2. So we call this pent 2-ene. Okay, to get from there to there, all you need to do is flip the molecule. Okay, so we're just taking that, flipping it, and we get that molecule. So they're the same. Yeah, they're the same. Right, next one, a wee subheading, is going to be branches. Okay, so what happens when we get a branch on an alkene? Okay, now, in alkanes, in fact, wait there, I'm going to draw a molecule out. You guys draw this as well, please. Okay, now, what side do we make carbon 1? Okay, because if we start there, the side closest is the carbon-to-carbon double bond. If we start here, the side closest, that's the side closest to the branch. So, what takes priority? Because in alkanes, I told you to start from the side closest to the branch. In alkenes, I'm telling you to start from the side closest. So what one do we do? Okay, now, what you should know, and this is very important, is that functional groups always takes priority. Okay, and that is so important. So functional groups always, let's go that S out. Functional groups always take priority. Okay, now what we mean by that, carbon-to-carbon double bond, that is a functional group. Okay, and the reason we call it a functional group is because it has a function. Okay, it does have a function, but we're going to learn about that next lesson. Okay, so all you need to know is that functional groups always take priority. So the first one, that's carbon. So we start from the left because that's the side closest to the functional group. So that's 1, 2, 3, 4. Very much like what we do in alkanes, we circle the branch. Okay, now what you want to do is you want to name the longest chain. So we need to name this chain here. Okay, now how many carbons does it have? 1, 2, 3, 4. So that is but, because it's 4. Now remember, it's an alkene now, so we need to sort of focus on the carbon-to-carbon double bond. Okay, so carbon-to-carbon double bonds between 1 and 2. So what do? We select the lowest number. So this becomes but 1 ene. Okay, so we've named it. Now, all we need to do now is name our branch. So that branch there contains 1 carbon. So that's meth, Because it's a branch, it becomes methyl. Okay, and then what number is it on? It's on number 3, so this becomes 3-methyl but-1-ene. And that's it. Okay, I'm going to give you, I'll give you one more, and then we'll go, you can do some questions. So good, we'll do this one together. This is it's a wee bit harder, but it's okay. So again, remember, each carbon can only have 4 bonds coming out. This carbon has 1, 2, 3, 4, so we don't put any H's there. That carbon has 1, 2, 3, 4, so we don't put any H's there. Just be careful with that. Okay, now let's find our longest chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Our longest chain's 5. So do we start from here or do we start from there? We start from here because it's closest to the carbon-to-carbon double bond. So we make that carbon 1, 2, 3, 4, 5. Yeah? And then we can circle our branch. Okay? So because it's 5, it must be pent. Now, if we focus on the carbon-to-carbon double bond, the carbon-to-carbon double bonds between carbons 2 and 3, what number do we focus on? We focus on 2. Why? Because it's lower. Okay? So this long chain is pent-2-ene. Okay? Now, this here, this branch, how many carbons does it have? It has 1, 2. So it's not a methyl branch, it's an ethyl branch because it contains 2 carbons. And then what carbon is it on? It's on carbon 3, so it's 3-ethyl pent-2-ene. And that's it. Okay? So, questions. What I want you guys to do is tell me, why does methane not exist? Now I can't remember if we went over that or not, but have a think. Now meth, what's that the prefix of? And then what do alkenes always have to contain? That should give you a wee clue for that. Okay, I want you to name this molecule here. So give that a go. Yeah, think of your rules. What side do we start from? Blah de blah. This one, next one, we'll do another naming. I want you to name this molecule. Okay, and so that's sort of 2A, that's 2B, and then question 3, I want you to draw, okay, so I want you to draw, let's go for hex dash 3 dash ene, and then I want you to draw, okay, make this a wee bit harder, okay, I want you to draw 2, 4 dash dimethyl hex 1 ene. Okay, that should be, sorry if you can't see that, that should be ene. So I want you to draw hex 3 ene, and then I want you to draw 2,4-dimethyl hex 1 ene. Okay, right. I'll post the answers along with the previous one tomorrow at some point, so have a go, let me know how you get on. Thank you.